Hello and welcome to this video in which I'll walk through several examples of graphing systems of equations to find their solutions. I'm borrowing this activity from GeoGebra because it does a great job showing us how all this works. So let's say that this first equation here that I need to graph, it's y equals 3x minus 1 or plus negative 1. So what I'm going to do for the pink line is I'm going to go to negative 1 on the y-axis, graph there, and then I'm going to take this point, put it right there, and my slope is 3. So that means I go up 1, 2, 3 over 1. Good. The pink graph is correct. Now, let's use the purple one. It's negative 1x plus 3. So my intercept is plus 3 on the y-axis. Good. Now, this tends to throw off a lot of students. What do I do with negative 1x? Well, it's negative, so that means it's got to go this way, and I'm just going to go down 1 over 1. And there, I've graphed them both correctly, and I'm looking for this intersection. Where do they both overlap? And that's right here. So that's going to be at 1, 2. Hit enter, and I'm correct. Very good. So let's do a new problem. One more. And then I want to talk about something. Ooh, all right, so this one got real. For the pink one, we have y equals 16x plus negative 7. So now I need to move this down here to negative 7. Let me get the purple point out of the way. Pink one, I need to go up 1 over 6. So up 1 and then over 6 like that. Good. And then here I have plus 8 and my slope is 8 over 3. Okay, so now this is a good example because I can't go up 8. Like the graph doesn't work like that. But I have another option. I can go down 8 and to the left 3, and I'll still have a positive line. So 1, 2, 3, 4, 5, 6, 7. Oh, miscounted. There's 8. All right, and then over 3. Good. They're both correct. Look at this intersection right there. That appears to be at negative 6, negative 8. So negative 6, negative 8, enter, boom. We've solved some systems by graphing them. Now, while I have this up, I want to highlight how graphs tell us, whether or not something has no solution, one solution, or an infinite number of solutions. So here we can see these two lines clearly meet at one point. And if we imagine the lines going on infinitely in either direction, we can see that's the only point they're going to meet at. Now, let's adjust it, make it a little easier on us. Let's just do it like that. And then let's go like right about here, right about here. All right, oh, no, not quite. All right, so let's see, 1, 2, 3, 4 over 3, perfect. Up 3, up 4 over 3. We now have two parallel lines. So you can't see it here, but these lines have the same slope. Uh, and since their slope is the same, they're never going to meet. And so this is why it's no solution. There is no x or y that works for both of them. And then sometimes we have it written in a way where we have the same solution or the same equation written twice. And so when you go to graph it, it might like algebraically it might look different. One could be in slope intercept form, one could be in standard form, one could be in point slope form. But when you graph it, it's the same thing. And so that means you can pluck any of these xy points and you can use them as a solution. And even like the ones that don't go through perfectly, use the decimal approximates or the fractions, and it works. And you have an infinite number of those because it's the same line. So hopefully taking a good look at these graphing examples, you have a better understanding of how you can find solutions from systems of equations by graphing, and also those different situations where sometimes you have no solution because lines just don't overlap, or you do have infinite number of solutions because they do overlap.